Hi everyone, welcome to my channel Design with Roosbe. Continuing with CSWA Practice Problems, today we'll work on question 5.15. Let's take a look at this question. In this question, unit of measurement is millimeter gram second. Like always, we need to ensure we are using the same unit of measurement in SolidWorks setting. Now, looking at this question, we have the top view, we have the 3D model, view AA, section B, right view, and front view. My preference is to focus on the top view. I'm going to make a sketch of the top view and base of the geometry. You can see this rectangle section. That's the base of the geometry. So I'm going to make a 2D sketch of that and then make that part of the geometry first. Then after that, I will focus on the second part of the geometry, which is this angled feature. I'm going to make an angled plane and then I will make a sketch on that angled plane, and eventually I will make this part of the geometry. And at the end, I'm going to focus on the small details like making holes or fillet. So with this introduction, let's jump into SolidWorks and start modeling this part. In SolidWorks, first we need to check unit of measurement, and you can see that we have millimeter gram second, which is a correct unit of measurement. Now, I can click on sketch, and I'm going to choose top plane. Here, I need a rectangle. So let's click on rectangle command and let's make a rectangle here. Looking at the top view, you can see that the height of this geometry is 100 millimeter. So click on a smart dimension and then let's add 100 millimeter as a dimension. Of course, we want this origin point to be placed on a middle point of this geometry. So what I can do, I can right click on this edge, select midpoint. Now the midpoint is selected, hold control, click on the origin of the geometry, and then choose coincident. Next, let's focus on width of this geometry. If you look at the top view, you can see that the distance between the center point of the left hole and the right hole is 130 millimeter. Also, the distance between the center point of the holes and the edge is 15 millimeter. So what we can do, we can simply add 130 millimeter plus 15 millimeter plus 15 millimeter. 115 millimeter is for the right circle, 115 millimeter is for the left circle. So overall width should be 160 millimeter. So click on OK, and that's it. Awesome. So now we have this part of the geometry made. Let's focus on a fillet in the corners. In order to make fillet, click on the sketch, click on fillet command. According to the top view, the fillet radius should be 15 millimeters. So let's change this one to 15 millimeter. And now let's click on left corner. Of course, you're going to get an error like this because you already used the midpoint of this line, and SolidWorks now tells you that this relation is going to break. But don't worry about it. If you click on yes, it's not going to make a problem for you. So just simply click on yes. Select the other one, and select this. Same thing, click on yes, and that's it. Now click on OK, and now you have the fillet in the corners. Okay, so now we have the fillet. It's time to add circles to the center point of the fillet. So click on circle command, and then make 4 circles. According to the top view, the diameter of the circle should be 12 millimeters. So this is 12, this is 12 millimeter, and finally this one is also 12. Alternative option was to assign 12 millimeter to one of the circles and then use equal relations between all 4 circles. Here, because it was simple, I simply chose to add dimension to all of these circles. Okay, so now we have the geometry fully defined. We are ready to use extrude bus feature. Click on feature, click on extrude bus, and then here for the thickness, you can see from the front view that we need 15 millimeter thickness. So this is going to be 15. Click on OK, and that's it. Awesome. So that's the first part of the geometry, the base of the geometry. Next step, we need to focus on making an angled plane in order to make the second feature. If you look at the front view, you can see that we need an angled plane with a 30-degree angle with respect to horizontal plane. If you remember previously, I mentioned that if you want to make an angled plane, all you need is two references. The first one is a reference plane. It could be any surfaces or any planes. And the second one should be axis of rotation. This could be edge or axis. So let me show you how to make that angled plane here. In order to make a plane, click on Feature, click on Reference Geometry and choose Plane. Of course, I want to have a reference plane, so I'm going to select this top surface. By default, SolidWorks gives you a plane parallel to this surface with a 10 mm distance, but we don't want this. So click on a second reference, and for the second reference, I'm going to select axis of rotation. And here the axis of rotation is this edge, the edge that you can see with the orange color. Click on it. And now SolidWorks by default make this plane perpendicular to the original plane. But we don't want this. We want to define an angle. Now, if you go back to the first reference, you can see that there is angled option. Click on it and change the value to 30 degrees. And now you can see that we have a plane. The plane is fully defined. Click on OK, and that's it. So basically now I have a plane. This plane is made from the top surface, and by rotating this surface 30 degrees around this axis of rotation or this edge. Okay, awesome. So now we have this plane. Everything is ready to make a sketch on it. Click on a sketch, click on a sketch, and choose top surface. Here, just to make my life easier, let's click on center line and make a symmetry line here. Now, first, let's start with making a large circle. We need a 75 mm circle, so the dimension of this circle should be 75 mm. Click on line command and then make a vertical line, go to right and go up. The width of this section according to view AA should be 35 mm. So this is 35 mm. Also, we want this section to be symmetric. So I click on the left line, hold Control, click on the center line, click on the right line, and I choose symmetric. The distance between this bottom edge and center point of the circle is 100 mm. Okay, so this part of the geometry is fully defined. Now let's add another feature to the right side of this geometry. Click on line command, and then let's start from here, go to right. I'm not changing the command, it's a still line command. Just move your cursor out and move it back to this point, and SolidWorks automatically changes the command to arc. Now you have arc command, click here, and now again the command is back to line command, and just go to left, and that's it. Looking at view AA, you can see that the center point of this arc should be in a horizontal line with the center point of the main circle. So hold Control, select these two, and choose horizontal. According to view AA, the width of this section should be 30 mm. Okay. And we also need another circle in the center of this geometry. The diameter of this circle should be 13 mm. So this is 13. As you can see, we added all dimensions, but still this geometry is not fully defined. If I click on this point as an example, I can move it right and left. So now we need to think about another way to make this one fully defined. Let's go back to the question I want to show you in detail. Here in this question in view AA, you can see that if I zoom in this area, the hole, you can see that the center point of the hole is in line with the right edge of the geometry. So this is the right edge, and this is a center line or center point, and you can see it's falling right on top of this edge. So if I add this constraint, that should be enough to make my geometry fully defined. So let's go back to the model and add this relation. So here, as I mentioned, I need to make sure that the center point of the circle is falling right on top of this edge. So click on center point, hold Control, click on the edge, and click on coincident. And now you can see the geometry is fully defined. I also need another circle, another hole in the center point of this geometry. So click on circle command and make a hole here. The diameter of this hole should be 30 millimeters. So this is 30 millimeters. Now we have the geometry. You can see that this is ready for the extrusion. Now we need to extrude this part of the geometry in 2 steps. The first one is going to be an extrusion with 15 millimeter thickness. So let's do that first. Click on feature, click on extrude bus, and then here I select this contour, this one, and this one. Change the direction, and we need a 15 millimeter thickness. Okay, so click on OK, and that's it. That's the first part. For the second part of the feature, we need to take a look at section BB. Section BB is basically showing what's going on underneath this surface. If you look at section BB, you can see that the section is showing you a new feature which is right underneath this surface. So we need to make that a sketch and then extrude it. So let's do that. In order to do that, click on the sketch, and doesn't matter. You can select this surface or you can select this surface, whatever works for you. I select this top surface. Now all I need is to make a sketch for section BB. So click on center line first to make a symmetry line. Then click on circle command. Of course, the inner circle is same as this circle, and we need another circle as well. Add dimension. The diameter should be 30 millimeters. The diameter of the outer circle should be 50 millimeters. We also need line like this. Same as previous step, we need a symmetry relationship. So click on bottom line, hold control, center line, top line, and choose symmetric. Also, the width of this section is 15 millimeters. So this is going to be 50. Now you have a fully defined geometry. Next, click on feature, click on extrude bus, and then here, all I need is to change this one to up to surface, and then for the contour, I can select this contour, this one, and this one. And for the surface, I'm going to select this surface. So I'm asking SolidWorks to extrude this up to this surface. Click on OK. Awesome. So now we made this second part. The only problem is that when you make this part, you don't have a through hole. If you look at view AA, you can see that we need a through hole. We need this hole to go all the way to the back side, but here, because I extruded this part up to this surface, the hole is kind of closed. And the solution is easy. We can just make a hole here and extrude it all the way to the back side. So let's do that. Click on the sketch, and choose the up surface, and then click on circle command, and then just make a circle. The dimension is clear, it should be 30 millimeters, so that's it. And then click on feature, click on extrude cut, and then here I want to go through all. Click on OK, and that's it. So now I have this part of the geometry made. Okay, so now we basically covered every single feature in this geometry. We made the base of the geometry. For the second feature, we made the first part, we made the second part. We also made sure that the hole is going all the way to the back side. So we covered everything. And now as a last step, I'm going to focus on the small details. If you look at view AA, you can see that we need fillet in the corners. Clearly in this view, you can see that we need 15 millimeter fillet. So let's add that feature. So in order to add fillet, click on feature, click on fillet command, and then here I'm going to change the radius to 15 millimeter. Now here we need 15 millimeter fillet in this corner, and finally fillet in this corner. Click on OK, and that's it. So that was the last step, and now I think we covered every single detail in this geometry. Now it's time to check the total volume and make sure that this is a correct model. So let's go back to the question and check the total volume in the question. In the question, you can see the total volume here. The total volume is 374,749 cubic millimeters. Let's go back to SolidWorks and check the total volume for our model. In SolidWorks, in order to check the volume, you can click on Evaluate and Mass Properties. And here you can see the total volume. The total volume for our model is 374,749 cubic millimeters. This number is exactly same as the number shown in the question, which is showing our model is correct and there's no problem with it. Okay, awesome. That's it. That's a wrap for this video. I hope you find it helpful. If you have any questions, comments, please leave comments down below. Thanks again for watching. My name is Rouzbeh. Hope to see you again soon in the next videos.